So let's continue our discussion from the previous video. We will go to the Scikit-Learn. Basically, there are two data sets. We have the iris and the wine data set that are particularly used for the KNN algorithm. In this video, I will be explaining about the iris data set. You can code along with me, and towards the end of the video, you will also be able to find the link to the Google Colab notebook for the iris dataset. And as a bonus, I will also provide the code for the wine dataset. So let's get started. So this is the iris dataset. You will be able to find this dataset on the Sklearn. You can learn more about the dataset. Basically, this dataset consists of three type of iris flower. We have setosa, versicolor, and we have virginica. These are the three data set, or when I say the three classes of iris flower that we have. So we will do our classification in either of these three classes. And what are the features that we have? So typically we have four features, right? So we have sepal length, sepal width, petal length, and petal width. So this, now let's quickly take a look at the iris data set. Obviously, you can go to the Scikit-Learn and understand more about the data set. But in a snapshot, this is how the iris data set looks like. First, if I talk about the flower itself, the iris flower, it has two parts. It has petal and it has sepal. The lower part that you see, basically the outer part is the sepal that protects the flower bud, and petal is the colorful part that you see, and basically the attractive part of the flower. The purple part that you see, this is basically the petal. Okay, now coming to the classes, we have three classes, right? Or basically the three category of the iris flower. We have setosa, we have versicolor, and we have virginica, right? So these are my three classes, and we will use our data set and we will do the prediction in either of these three classes. So if there is an unknown variable, right, we will train the model first and then we will make the prediction. Now that prediction should fall in either of these three categories, right? So this is my target variable. It can be either setosa, versicolor, or virginica. One more thing to note here is we have 150 sample, and in the iris data set we have 50 sample for setosa, similarly 50 for versicolor, and 50 for virginica. So all the three categories, we have the equal number of samples. And if I talk about the features, these are basically our features, right? We have sepal length, sepal width, petal length, and petal width. All of these are provided in centimeter, right? So this is a very brief about the iris dataset. So I can start with importing the required packages. I will need NumPy, pandas, and from the sklearn dataset, I need the iris dataset, which is called as the load underscore iris. So I can import the required packages. Once this is done, I can load the data. The loading of data would mean that this load underscore iris, I will store this iris dataset in a variable called as iris. So this step is already completed. And once this is done, I can verify the data load. In order to verify the data load, I have to create a data frame for pandas, right? So df equal to pd.data frame of the iris.data, columns equal to iris underscore feature names. What this piece of code is doing is it says columns equal to iris dot feature underscore names. So all the columns it is basically considering as feature names, right? And if we want to see the name of the features, it is sepal length, sepal width, petal length, and petal width. Now, if we see the df dot head, or basically the first 5 records of my data frame, this is how it looks like, right? So we have sepal length, sepal width, petal width for the first 5 samples. Similarly, I can see the tail as well, right? So if I have to see the bottom 5 records, I can do df dot tail and I can run this. So the bottom 5 records also I can see, right? So basically it has how many? 150 records, because this is 149 and it started with 0. So we have 150 records that is 150 rows and 4 column, 150 into 4. So if I do the df.shape, it will give me the number of rows and columns. So this should be 150 into 4. Let us verify. So you can see that we have 150 rows and 4 columns in this data set. We can do the df.info also to see what kind of data exists, right? So you can see that these are the columns. These are the 4 columns and there are no null values, right? So because there are 150 values and all 150 are non-null values, and the data type is basically float. It has the decimal values. I can see that it has the decimal values. So this is how we verify the data load and do some basic analysis with the data that we have imported. Feature as the next step, I will need to store the data and labels into X and Y variables. So if you understand, whenever we have to work on machine learning, we discuss that y is equal to f of x. So any kind of data, you have to store the data and the labels into X and Y variables. So now if you see, whoever has created this iris data set, they know what is the meaning of data and they have defined what is the meaning of target, right? So if I do iris.data, I will be able to see this data. Okay, so this is all the data that is coming. And when I say data, this is basically a numpy array, and this is giving me the value of each of the features, right? So sepal length, sepal width, petal length, and petal width for 150 records is showing up here. That is what the data is. And when I do iris.target, here it provides the classes, right? So for each of these records, right? For each of these record, what exactly is the class? So some are 0, some are 1, some are 2, right? So 0, 1, and 2 are basically the three category of data, the three classes of the iris dataset. So if you remember, we have three classes. We have Setosa, we have Versicolor, and we have Virginica. So one of this is 0, one of this is 1, one of this is 2, right? So that is why you see 0, 1, and 2, which is basically the classes of the iris dataset. Now, once I do this and once I verify this data, what I have to do is I have to define the variable x and y, where x is basically my features, right? So x meaning the features and y meaning the target or the classes, right? Or basically my output, or I can also say classes. Okay, classes meaning for classification. Okay, so I define the x, I define the y, and finally I can see x dot shape, y dot shape, and type of x and type of y. So if I run this, I will be able to see that x equal to 150 comma 4, because this is what is this? This is my data. So I have 150 records, so 150 rows, and in the x I have 4 columns. What are these 4 columns? Sepal length, sepal width, petal length, petal width, right? Similarly, y equal to iris dot target. So target would mean that this column that basically provides the classes, right? So there is only one column and it has 150 rows, right? And these are the rows. Okay. And what is the type? Basically x and y both are numpy array, which is also called as the ND array. Okay. As a next step, I can also see and I can print the target, right? So this is how the target looks like. So if you remember, we have defined our x and y values, which are basically our features and target values, we can split the data into training and testing. So this is the exercise that we do for any machine learning model or any machine learning algorithm. We have to do the splitting, right? So for splitting, there has to be some data that we can use for training, and from the original data set, we will retain some records, we will retain some data, and we can use this data for testing purpose, right? So we are just doing the split. So in order to do the split from Sklearn model selection, we need to import the train test split, right? The next step, we have to define the value of x and y for training as well as testing. So x train, x test, y train, and y test equal to train test split of x comma y. Okay, now you need to be mindful of x comma y, how we provide, right? So typically whenever we provide x comma y, where x is the feature, we typically use the capital X, because there are multiple features, right? So in this case we have four features: sepal length, sepal width, petal width, right? So here we need to use the small x, but here we need to use the capital X. Generally, this is the trend that we follow while coding any of the machine learning algorithm, right? And y can be small because there is only one output or the one target variable. One more thing we have to understand is the training data, as I said, is used for learning, and testing data is used for evaluation. Similarly, you can see that we have not specified any testing size here. And whenever we do not specify any testing size, by default, the test size is 0.25. That is 25% of the records will go towards testing, 75% will be used for training. Obviously, if you have to be more specific, you can also provide something like test size equal to 0.3, which would mean that 30% of the total number of records should be going towards testing and 70% should be coming towards training. So this is how we define the X and Y for training and testing. Now, once we define all of this, we can also do the print and try to see the shape of X and Y that we have defined for training and testing. So if you see, we have 112. Now this 112 is nothing but the 75% of your 150 records, right? Similarly, 38 is nothing but your 25% of the 150 records, because total records is 150. And when I talk about the Y, we have only one column. So we have 112 and 38. Hope this is very clear to you. So this is how we define the X and Y. And we have also verified the values of X and Y that we have defined for training and testing dataset. As a next step, we need to train the KNN classifier. Now, for training the KNN classifier, we will need to import KNeighbor classifier. So you understand that Sklearn is the Scikit-Learn library. Neighbors means, so here the neighbors that you see, it is basically the module that contains the algorithm that are based on the neighboring data point. And one algorithm is KNN that we are using. So that is what we are doing. We are basically, from the algorithm that are based on neighboring data points, we want to use the kneighbor classifier, right? So the KNN algorithm used for classification task. So I will simply run this. In the next step, I can create an object out of the classifier that I have already imported. So KNN equal to kneighbor classifier. This is basically a function. And when I do not provide any value in the kneighbor classifier, by default, the value will be 5. But yeah, if I want, I can change this value to 3, 7, 5, 1, right? Anything. It can be anything, but by default, the value is set to 5. So even if you don't define n underscore neighbors, by default, the value will be 5. And once we create the object, we need to do the fitting, right? You need to fit the model. So knn.fit x underscore train, y underscore train, and knn.score x underscore test, y underscore test, right? So here we are storing the training data, and here we are storing the testing data. Sorry, it should be testing, right? So testing data. Okay, so let me run this. And you can see that we have got the score of 94%, right? So after doing the fitting, I am able to see that this is the score that I have got. This is basically the accuracy of my model. So the model is able to predict 94% of the unlabeled data correctly, right? So this is 94% accurate model. So now let's move to the next part and let us try to understand how we can visualize the KNN algorithm. So if you remember about matplotlib, if you are not very familiar with matplotlib, you can very well go and watch the video that I have made on matplotlib to get an understanding about the visualization and matplotlib. So basically we have to import matplotlib and also the pyplot. So that is what we did in the first piece of code. Then we move to the next part, which is plt.figure. Here we are trying to plot a scatter plot. Okay, so figure size equal to 8,5 would mean that 8 is the length, 5 is the breadth, and it is basically in inches. Okay, plt.scatter, and then I specify x, and this would basically mean that I want all the rows but the first column, right? So 0 meaning the first column. Similarly, this means that I would want all the rows but the second column, because the 1 would mean the second column, and c equal to y. So what is the meaning of c equal to y? So c equal to y would mean that the color equal to y. Color should be based on the target column, and in the target column I have 0, 1, 2, right? So if you remember the target column, we have the values like 0, 1, 2, which basically signifies each of these category of the iris flowers, right? So I am saying c equal to y, the color should be based on the classes that I have defined in the target column, right? And then I'm just doing the plotting of the scatter plot. So plt.xlabel, xlabel would mean the feature name that is at 0, right? That is the first column, right? So first column would be my x label, second column would be my y label, and plt.title is iris dataset scatter plot, and I can do the plt.show, and this is the way I am able to see the scatter plot. Okay, so you have sepal length and you have sepal width, right? Why? Because you are selecting 0, 1. You can also select 1, 2. So 1, 2. Similarly, you can do 1, 2 here, right? And if I try to run this time I see sepal width and petal length, right? Sepal, so it should be sepal width and it should be my petal length, right? This is just for visualization on how we visualize certain things, right? There are different features, and if we have to see these different features on the scatter plot, this is how we can plot. This is just for visualization. This has less to do with KNN and more to do with visualization, but I also wanted to include this part so that you get some visualization and you should be able to understand how the features looks like in the iris dataset. And finally, I will move to the evaluation part. There are some sort of evaluation we can do. Obviously, in the above piece of code, we can see that the model is providing some 94% accuracy, which is pretty good. And this is expected of the iris dataset given the structure of it. But we can also evaluate this KNN on different set of parameters, right? So these are some of the additional evaluation that I wanted to discuss with you guys. The very first thing is y underscore pred equal to knn dot predict x underscore test, right? So in this piece of code, basically I'm comparing the predicted values with the actual values. And what I'm typically doing here is I'm saying for the first 10 rows, what is the predicted value and what is the actual value. If I simply run this, right, this is what I'm getting. So the predicted value is 2. So this is for the first record. The predicted value is 2 and the actual value is also 2. For the second record, it is 0, 0. Third record 0, 0. Again 0, 0. 1, 1. 0, 0. Right? Likewise. So here you can see that it is basically 100% accuracy. Right? So for the first 10 records, it is basically giving 100% accuracy. Let us see for the first 20 records how it is behaving. Right? So if I do the 20 records, this is what it is. Let me see if there is any deviation. Okay, there is no deviation as such. Okay, And if I do the prediction for all the values, right? So all the values, this is what I have. Okay. So now here you will be able to see that there is some deviation, right? So for example, this value is 2, but this value is 1, right? So this is how it works, and you will be able to find some deviation when you see all the values. Anyway, we see that 94% accurate model, so it is pretty hard to find the deviation from between the predicted and the actual values. There is one more thing. The same piece of code, if I want to write in a more beautiful way, I can write like this, right? So sample 1, the actual value is 2, predicted is 2. Sample 2, actual is 0, predicted is 0, right? So you will be able to visualize everything. Okay. So here I am considering only 10 records. So I can also change the value here. Instead of 10 records, I can see the 20 records or maybe even the 30 records, right? And I can see that what is the sample number, what is the actual value, what is the predicted value. Then we can also talk about confusion metrics. This is also one important metrics that is used for evaluation, particularly for KNN models. So when I talk about confusion metrics, I need to import the confusion metrics from the Sklearn metrics section, and I can define a function, right? So I can say CM equal to confusion metrics, Y test, and Y prediction, right? So I need to deal only with Y values, right? Because Y is the output here, right? So the test versus predicted, right? So if I print, this is what the confusion matrix looks like. Now let us try to understand this confusion matrix, and let us try to understand how to interpret this confusion matrix. So if you see the elements of this confusion matrix, the values that we have is 1500. So let me just write the values here quickly. So I have 1500. Similarly, I have 0, 10, and 2. So I will write 0, 10, and 2. And then I can write 0, 0, and 11. So 0, 0, and 11. So this is what the confusion matrix that I have got as a result of evaluation. And what it basically signifies is the values that you see here are basically my actual values, right? Actual values. So actual values, and the values that you see here are basically my predicted values. So if we see the data set of Iris, we have basically three classes, right? So we have 0, 1, and 2, right? So we have 0, we have 1, and we have 2. Similarly, we have 0, we have 1, and we have 2. What is the meaning of 0, 1, and 2? Basically, these are the three categories or classes of iris flowers, right? So what this confusion matrix talks about is there are 15 cases when the actual values of when the actual value was 0 and it predicted also 0, right? So this is the correct prediction. There are 10 cases when the actual value is 1 and the prediction is also 1. This is the correct prediction. And then there are 11 cases when the actual value is 0, when the actual value is 2 and the prediction is also 2. So this is also a correct prediction. In rest all the cases, the prediction is not correct, right? So this is not correct prediction. Okay, all of these cases are not correct predictions. So now you can see that if we take a look at the test data, that how many uh, number of rows and columns we had for the test data. So you can see that 38, right? Which is basically the 25% of my 150. So you can see that I had 38 records that I use for testing. So if you sum up everything here, that is, if you sum up 15 plus 0 plus 0 plus 0 plus 10 plus 2 plus 0 plus 0 plus 11, right? It will sum up to 38, which is 25% of my 150 records that I use for testing. And for all of this record, what is the evaluation, right? So it is able to predict 15 plus 10 plus 11, right? 15 plus 10 plus 11, which is 36. So out of the 38 records, 36 it is able to predict correctly. And there are these two records that it has not predicted correctly, right? And also if you want, you can also see the detailed metrics. For this, you have to import something called as the classification report. And this classification report will have a variety of metrics. So for example, we can have precision, recall, F1 score, and support. All of these metrics you will be able to find if you import the classification report. And also if for today, and I will provide the notes that we discussed and also the notebooks for Iris as well as the other data set that I will provide as a bonus. You can check the description section and download the notebooks and the notes. I hope by this time you must have got a good idea about the KNN algorithm. Thanks for watching, and I hope to see you in the next video.